Okay, here we go. Um, for this assignment, we're looking at multiple rigid motions. So here we're comparing Paula to Keenan. So with Paula, she says that rigid motions, when we do a composition of transformations, it's commutative because you can do it in either order. You can do the translate first, then the reflect, or the reflect and translate, and the same figure will end up in the end. Keenan says, no, that's not right. Because if you rotate, then reflect and rotate, it won't be the same figure. Because he rotated a positive 90 degrees and then reflected across the y-axis. Then he reflected across the y-axis and rotated a positive 90 degrees. And see how the shapes don't end up at the same spot? So rigid motions are not commutative. And since we have one example where it doesn't work, then we know he must be right. Because for Paula's to work, it has to work every time on every example. Well, it doesn't. All right. What this says is no matter what you do, if you reflect, you translate, or you rotate, or whatever, if you start with a rigid motion doing this and you do a composition and transformations, you'll end up with a rigid motion, okay? They'll always be the same, okay? It's only when you start dilating where they're not a rigid motion. Okay, so how do we get this figure down to this figure? Well, what we have to do is a composition of transformations. We can do a translation, then reflect, or reflect and do a translation. So I like to reflect first. So we're going to reflect across the y-axis. So let's reflect across the y-axis. So if we are, B is 3 away, so B would be 3 away. C is 3 away, C would be 3 away. A is 5 away, A would be 5 away. So that's a reflection around the y-axis. Then what we have to do is slide it this way. So A goes back 2 and down 5. So that's a translation of back 2 and down 5. And that's our composition of transformation, which is called a glide reflection. We glide and we reflect in that problem. But the order is not commutative. Okay, you have to do this first and then this for it to work. We're going to skip over the tread one and go to this one. Now, if we translate PQM up 4 and then reflect it across the line N where it's x equals 4, do we get KJN? Well, let's see. The first thing we're going to do is translate it up 4. So PQM, which is right here, we're going to translate up 4. 1, 2, 3, 4. That's PQM. Okay? Then it says reflected across the line x equals 4. So we'll do that in red. So here's the line x equals 4. So M goes to there. It doesn't move because it's on the line of reflection. P is to the left, so we go 2 to the right. And then Q was there. It's to the left, go 2 to the right. So we see that it's KJN, which is what we're after. So yes, that is correct. We slid up and then reflected over. So any rigid motion is either a translation, reflection, rotation, glide reflection, or some other type of composition of transformations. Okay? So you could do one thing, 2 things, or 3 things to get a composition of transformations. So here we're going to do 2 things. to get from A, B, C to A prime, B prime, C prime. So to get from here down to here, since B is on the top and now B is on the bottom, it looks like we must have had a reflection. So we reflect across this line, and the line is called y equals -3 because it's 3 down from the origin, okay? And a horizontal line is y equals. So our first thing we're doing is reflecting across the line y equals 3. Then we're going to slide it this way while B slides 1, 2, 3, 4, 5 to the right. So it's going to be a translation of 5 to the right and up 0. So this is how we map it. This one, we have 3 things to do. We're going to rotate this because see how J and L are on the bottom and they should be on the top. And it's more than just a simple flip. Well, I guess we could flip it around the x-axis and glide it. Let's try that. Maybe we'll do it that way. So let's flip it first. So we're going to flip it around the x-axis. So it's a reflection around the x-axis. So K flips down to be 3 below. L is 2 above. And J is 2 above. J prime, K prime, L prime. And now everything moves this direction. So we're going to translate 1, 2, 3, 4, 5 to the right and 2 up. 5 to the right, 2 up. That's our composition of transformations. Okay? Make sure you do this first and then this. Okay? So that's the basics of what we're doing today in this classification of rigid motion. Okay? So if you need to rewatch it, you can. All right. Have a good day. Bye.